Hello everyone, today we're going to be working on fundamental problem 6.3, and this problem is asking us to determine the forces in the members AB, AC, AD, BC, and CD. So as you guys could take a look at the figure, we have two forces at point A and point B with a value of 640 pounds and 480 pounds. So to determine the forces of the members, the first thing that we're going to do is determine how many reactions there are. So if we go and look at point A, we could see that we have a roller, meaning that we're going to have one reaction. And I'm going to assume that it is going upwards, or in this case for us, to the right. I'm going to call it A of X, since it looks horizontal to us. And then from there, if we take a look at point D, we have a pin support, meaning we're going to have two reactions. I'm going to assume now that for that reaction that's going upwards or downwards to that wall, I'm going to assume that it's going to the left. I'm going to call it D of X. And then from there, for our other reaction, I'm just going to assume that it's going upwards in our point of view. I'm going to call it D sub Y. So now that we determined that there's going to be three reactions, now I'm going to determine the values of each of those reactions. So that's our first step. So I'm going to start off by taking the sum of the forces in the y direction, since we have only one missing y force, and then we know already two of them. So the sum of our forces in the y direction have to equal 0. We assume that d sub y is going to be going upwards, so positive d sub y. Then we have minus 640 pounds minus 480 pounds. We know that all of that has to equal 0. We end up getting that d sub y that equals 1,120 pounds. And since we got a positive number, that means we assumed correctly. So we do know that that reaction will be going upwards. From there, if we were to take the sum of the forces in the x direction, we wouldn't be able to determine the values since we have two unknown forces. As you guys could see, d of x and a of x. So because of that, what I'm going to do is I'm going to take the sum of the moments about point D. That way, d of y wouldn't be creating a moment, d of x wouldn't be creating a moment, and that way I'd be able to solve for the value of our reaction a of x. So counterclockwise, positive. The sum of our moments about point D have to equal 0. Remember that a moment is equal to the force times the distance. So our a of x, we know that's going to be creating that counterclockwise moment. From there, our force is what we're trying to determine, and our distance is going to be the 3 feet. So we said positive moment, force, that's what we're trying to determine, times the distance, 3 feet. From there, we have our 640 pounds. That is also not going to be creating a moment since it's already parallel to that point D. And then, so then from there, the only other force creating a moment is our 480 pounds. This one, since it's going downwards, we know that's going to be creating a clockwise moment. Our force is of 480 pounds and our distance is of 4 feet. So negative moment. force 480 pounds times the distance of 4 feet. We know that all of that has to equal 0. From there, if we were to solve for a of x, it would end up that a of x equals 640 pounds. We end up getting a positive number, meaning that we assumed correctly. So we do know that our reaction will be acting to the right. Now we could take the sum of the forces in our x direction to determine the value for d of x. And then from there, our two horizontal forces are just our a of x and d of x. We already determined that a of x will be going to the right, so positive reaction, and d of x, we assume that is going to the left, so negative reaction. So positive 640 pounds minus d of x has to equal 0. When we solve for d of x, we also get that d of x is equal to 640 pounds. We get a positive number, meaning that we assumed correctly that our reaction will be going to the left. And so now that we determined the values of all of our reactions, the next thing that we're going to do is I'm quickly just going to put in the values of each of our reactions. So now that we have all of that, now we could determine the forces of each of the members. So I'm going to quickly just move to the side of my work of the reactions. So now to determine the forces of each of the members, what I'm going to be doing is using the method of joints. So if I were to take a quick look at this, I'm going to start off with joint D. That way, with doing joint D, I'd be able to determine for the force of the bar AD and CD. So I'm going to start off with joint D. So if we were to draw out joint D from joint D, which is right there, we have our reaction of D of Y going upwards with a value of 1,120 pounds. From there, we have our reaction D of X going to the left with a value of 640 pounds. And then from there, we would have our forces of AD and bar CD. I'm going to assume that they're in tension, so away from the joint. I'm going to call this force AD, since it's the force of the bar AD. And I'm going to call this force CD. So to determine the values of each of the forces of the bars, I'm just going to take the sum of the forces in the X and Y direction to determine their values. So I'm going to start off with taking the sum of the forces in the Y direction. We know that has to equal 0. We have 1,120 pounds going upwards from our reaction. And then from there, we assume that the force of the bar AD is going to be in tension. So in this case, it's going downwards, so negative. Force of AD has to equal 0. We end up getting that the force of the bar AD is equal to 1,120 pounds. Since we got a positive number, that means that it's in tension. Remember, if you were to get a negative number, that means that it is in compression. So with that, we already determined one of the forces of one of the bars or members. Now I'm going to take the sum of the forces in the X direction. We have negative 640 pounds. And then plus the force of the bar CD has to equal 0. If we solve for the force of the bar CD, we end up getting that it has a value of 640 pounds. Once again, a positive number, so that means that it's in tension. So now that we found the forces of those two bars, I'm just going to quickly just check them off. So from there, what I'm going to do now is I'm going to be taking the method of joints about joint B. So with doing joint B, I'd be able to determine this force and this force right here. So that's going to be my next joint. So if we were to draw joint B, we'd have our, I'm assuming that all of the forces are in tension, so away from the joint, and that would be the force of the bar BC. From there, we would have the force of the bar AB. And then from there, we would have a reaction of 480 pounds going downwards. Now, as you guys could see, we could already see that the force of AB is going to be having a value of 0, but we're still going to show the work for it. But I'm going to start off by taking the sum of the forces in the x direction to determine the value of the force BC. Since we get a positive number, we know that it's going to be in tension. From there, we're going to take the sum of the forces in the x direction. And then from there, as you guys could see, the force of the bar AB is the only force, which is why we would get a value of 0 pounds. So with that, we could go quickly right here. This we know has a value of 0 pounds. From there, we know that the force of BC is 480 pounds in tension. For this one, we got 640 pounds in tension. And then from there for AD, we got a value of 1,120 pounds in tension. So from there, we just have the only two bars that we're still missing is, sorry, no, just one bar that we're missing is bar AC. Because with that, we already did the ones on the outside. So because of that, I'm going to be now taking the method of joints about joint A to determine for that last member. So if we were to draw joint A, we'd have a reaction of 640 pounds going downwards. From there, we would have our other reaction of 640 pounds going to the right. From there, we have the force of our member AD, which we found out to be in tension, so away from the joint, with a value of 1,120 pounds. From there, you don't really have to draw it out since we do know that it has a force of 0 pounds. But if we were to draw out the force of the bar or member AB, that one would simply just be 0 pounds. And then from there, the one that we're trying to determine, the force of the member AC. So From here, as you guys could see, the bar or the member AC is at a incline or at an angle. So we could either take the sum of the forces in the X or Y direction, and then we could just solve using either one of those. But to solve that, we're going to quickly look back at the figure. As you guys could see, we know that this side has a length of 4 feet. This side has a length of 3 feet. So we could see that this is a 3, 4, 5 triangle. So we know that the hypotenuse side would have a length of 5 feet. So we could quickly just put that in here. So 3, 4, 5 triangle. There we go. So what I'm going to do is I'm just going to take the sum of the forces in the x direction, since it would just be the force of the member AC and the 640 pounds. If you were to take the sum of the forces in the y direction, you would still get the same answer, so it doesn't really matter. So we have positive 640 pounds. And then from there, since we assume that the force of the bar or member AC is in tension, we do know that it's going to be, because it's in tension, it's going to be away from that joint, and because it's away from that joint, in this occasion, it's going to the right, so that would be a positive force. And then from there, since we're doing the sum of the forces in the x direction, we're trying to determine its horizontal component to it. So we're going to be multiplying the force by 4 over 5. If we were to be taking the sum of the forces in the y direction, we'd have a positive 120 pounds, a negative 640 pounds, and to determine the y component of this force, we would be multiplying the force by 3 over 5. So since we're dealing with the horizontal component, we're going to do 4/5 times the force of AC. And we know that all of that has to equal 0. So we end up getting that 4/5 of the force AC has to equal negative 640 pounds. From there, if we were to solve for the force of the member AC, we would end up getting a negative 800 pounds. And because this number came out negative, we do know that that means that this force or this member is going to be in compression. And with that, we could simply just go up here and write now that this member has a force of 800 pounds and that it is in compression. So with that, we were able to determine all of the forces in all of the members. So just a quick overview. The first thing that we did to solve this problem is we first took a look at the figure, determined how many reactions there would be based on the supports that we had, a roller and a pin support. From there, we determined the values of each of those reactions. And once we determined the values and the direction of those reactions, then we determined the forces of the members, and we did that by using the method of joints. I started off with joint D, solving for 2 members. Then from there, I proceeded to do joint B, solve for the other 2 members. And then lastly, I did joint A, solving for the last member. Thank you guys so much. Thank you guys so much for watching this video. If you found this video helpful, please feel free to like this video, and also feel free to subscribe to our channel if you guys would like to see more videos like this.